Okay. Let's move on a little bit. Do you remember when I defined complementary angles and supplementary angles in last class period?
I do remember.
Yeah. And I said complementary angles are what?
Two angles that have to be 90.
Two positive angles whose sum is one right angle. Well, guess what a one right angle is?
1.57
Pi over 2 or 1.57. Do you see why I didn't put 90 in there?
Yes.
Because I defined it once already and now taking care of it for both measurement systems.
Wow.
Do you see why the supplementary angle being the sum is two right angles, being pi radians? I didn't have to put a number in there. I have to talk about what my measurement system is. So we will want to calculate complementary angles and supplementary angles in radians. And I want to show you how this looks, because for some of you you're going to go, oh boy. By the way, you really can't use your calculator for this either.
Right? You got
I told you we really didn't need this.
Oh boy.
You got a lot of time to build these skills.
We're going to get our brains aren't calculating.
For homework?
Yeah.
Let me see them.
It's a fraction. Oh, guys.
Do we get a car?
Oh man, my back's been hurting lately, you know?
What?
Do we get a calculator on the back?
If you want to use one, I don't know how much it's going to help you.
What is the
Well, it'll help you know what the fractions are in decimal form.
Okay. So we're going to work with the radian angle of pi over 6. And we want to be able to try to find the complementary angle and try to find the supplementary angle for that. Now we said that by definition, the complementary angle is two positive angles. So theta plus phi, that equals one right angle, pi over 2.
Yeah.
Then we have a number or value that we can plug in here for theta. And so we can then say that pi over 6 plus phi, which is going to be the complement, is pi over 2. Now, in order for us to get this simplified, what has to exist?
A variable.
We got fractions, correct?
Yeah.
Decimal.
So in order for fractions to be subtracted or added, what has to exist?
Same denominator.
Common denominators. So let's multiply by 1.
So we got 3 pi's over 6 is that.
If I take pi over 2 and multiply it times 1, will that give me a common denominator? I'm hoping you will say so.
I'm going to guess so. Right on the board.
What's 2 times 3?
6.
Is that 6? Max that 6?
Oh, yeah, it does.
So did it give me a common denominator?
It did.
Yes.
All right. So what's 3 pi's over 6 minus 1 pi over 6 gives you what?
2 pi's over 6.
Which simplifies to 1 pi over 3. There is the complement of my pi over 6 angle.
That wasn't
Theta.
That wasn't awful, yeah.
Good. I'm glad to hear it wasn't awful.
I don't know.
Holy shit.
Actually, no. If you can do that, you're good.
How did I get 8 cards?
You're not going to add in like crazy numbers or anything.
None of these numbers are crazy. These are easy numbers.
That's funny.
Okay, will the numbers get crazy?
Well, now you're asking me to subjectively decide if numbers are crazy or not. I don't think they are. So no.
So, yeah.
Will they be more complicated than this?
Yeah.
I don't think so.
Yeah.
I mean, yeah. All right. I feel like you'll understand what we're trying to say to you.
I mean, I might use something like 5 pi over 12.
Okay, that's
I could use something like 7 pi over 18. I could. I didn't say I was going to.
Thank you.
That's still not that bad.
You keep up reverse.
Okay, so now for supplementary angles. For supplementary angles, we have two angles that add to be two right angles, correct? Okay, so theta plus alpha is equal to pi.
Theta plus alpha.
Beta plus alpha equals pi.
You just say it like
That's an alpha.
That doesn't mean I did
It's a
it.
lowercase alpha.
No fish.
Lowercase alpha.
That doesn't look like a fish.
Oh my
This
goodness.
doesn't have a fin. It's uncompleted.
Well, some fishes are different.
It looks like a bomb pop.
Looks like an alpha to
Ring
me.
pop. Looks like a ring pop.
You do not have to use alpha.
It looks like a twist tie.
No.
Okay. Now,
Look at all them fishes.
once again, I'm back to the question.
I could have put her in.
I'm back to the question. If I subtract pi over 6, what has to exist?
A common denominator.
So we're going to multiply by 1, aren't we? You have a question or a comment?
Yeah, where do you get?
That is given to you as the original problem. Well, we're just asking the question, what
Where
is
is that on the
the
coordinate?
5 or 6?
That's why you only have 3 wins.
What is 1 6 of the way, all the way?
Oh, 1 6.
1 6 5.
The total way. Which means that what's left is 5, 6.
Like
Yeah,
all of
exactly.
5 pi.
So are you going to multiply that times 1?
Yes.
How do I know it's 6 over 6? What's this denominator right here?
No. What,
Oh.
what are we supposed to be subtracting?
Yeah.
Didn't we subtract in the last one?
Yeah, we did.
Yeah,
That's a
From,
subtraction.
yeah, but why are we subtracting?
Because I want to get alpha by itself. And algebra tells me that I have
Oh,
to
yeah,
get...
you're cool. Oh, my bad, Carter.
Hey. Are we paying attention?
Yeah,
Are you sure?
yeah.
So alpha is equal to 5 pi over 6.
So the fish.
That's the supplement.
Okay. I think we should just call it.
This isn't too bad.
Okay, why? We could have just figured that out.
Oh, we're on YouTube still? Oh, snap.
Now, by the way, guys, you're talking about fish there. Understand, that's the Greek letter gamma.
And that's the
Gamma?
That's downward swimming fish. Okay, you're talking about fish.
That's just not a gamma ever.
I drink gamma.
That's a Debbie.
Is there an upward fish?
No, it's not.
It's just an L.
Okay, listen.
Come on, baby.
I am hoping that with these two sets of problems, you're getting the complements and the supplements, and you're getting a way to see the equations that work so that you can be successful in doing those kinds of questions. Because I'm going to ask you to do some for homework as well.
I gotta draw more fish.
Yes, you do have to draw more alphas. Okay.
Yeah, what if we write out
The fish is just a lowercase that, right?